Hello students, now we will discuss about surface acoustic wave sensors for pressure.
Surface acoustic wave, that is SAW sensors, is a micro electromechanical devices that uses acoustic waves traveling along the surface of a material to measure various physical phenomena such as pressure, temperature, vibration and gas. Working of SAW sensors. SAW sensors converts an electrical signals into mechanical wave. Mechanical wave propagates along the surface of the material. The wave propagation speed is affected by various phenomena such as absorption of gas on a sensing layer. The change in propagation speed causes the changes in resonance frequency of the device. The device that converts the change in frequency into electrical signal. Application. It can be used in industrial monitoring, automotive, medical devices and telecommunication. In industrial monitoring, it can be used to measure pressure, humidity, vapor, gas and vibration. In automotive industries, it can be used to measure torque, tire pressure. Medical devices used in medical diagnosis because of high sensitivity. In telecommunication, it is used in mobile phone and base station as band pass filter. Advantages. High sensitivity. It can be capable of detecting very small changes in pressure. Wireless and passive operation. Many SAW sensors can operate wirelessly and do not require an internal power source, making them suitable for remote sensing applications. Disadvantages. Complex fabrication. The manufacturing process can be complex and costly. Second one is environmental sensitivity. May require careful calibration and compensation for environmental factors like temperature. SAW sensors provides a robust and sensitive solution for pressure measurement in various challenging environments, offering benefits that are particularly valuable in industrial and automotive applications. SAW pressure sensors utilize piezoelectric substrate and interdigital electrode IDE to detect the pressure changes by measuring the alteration of propagation speed of SAW, which is affected by the strain induced on the substrate due to applied pressure. Working. When the pressure is applied to the sensor, it induces a strain on the piezoelectric substrate, which in turn affects the propagation speed of the SAW traveling across the surface, causing a changes in the sensor. Components. Piezoelectric substrate. The core component of the SAW sensor is piezoelectric material like quartz, lithium, niobate, which generate electricity when mechanical stress is applied. Second one is interdigital transducer. These electrode patterned on the surface of the piezoelectric substrate are used to generate and detect the SAW. Third one is signal detection. The change in the propagation time is detected by the receiving IoT, which convert the mechanical wave into electrical signal. This is the piezoelectric material having SAW sensors and IDT material. SAW humidity. The humidity sensors are devices used to measure the moisture content in the air. One common example is DHT11 sensors, which is frequently used in various IoT projects and educational applications due to its simplicity and ease of use. DHT11 sensor functionality. The DHT11 sensors can measure both temperature and humidity. It uses a thermostat to measure temperature and a capacitive humidity sensors to measure the air moisture. Data output. The sensor provides digital output which can be easily read by microcontrollers like Arduino. It requires a dedicated library to interpret the data correctly as it communicates using custom one-wire protocol. Types. It has 3 types: resistive, capacitive and thermal. Working. There are different types of sensors, but most them will work by measuring the changes in electrical properties like resistance, capacitance and temperature caused by moisture in air. First one is resistive humidity sensors. It utilizes ions in salt to measure the electrical impedance. Second one, capacitive sensor. It measures relative humidity by replacing a thin strip of metal oxide between two electrodes. Thermal sensor. Two thermal sensors conduct electricity based on a humidity of the surrounding air. One sensor used in nitrogen and another in the ambient air. How to use with Arduino. First one is connection. How we have to connect the sensor? Connect the DHT11 sensors to the Arduino board. Typically, this involves connecting the VCC pin of the sensor to the 5 voltage pin on the Arduino, the ground pin to the ground, and the data pin to the digital pin on the Arduino. Library. It includes the DHT library in your Arduino IDE, which helps in reading the data from the sensor. Code. Write a sketch that initializes the sensors and reads temperature and humidity data and display the results on the serial monitor. SAW humidity. A SAW for measuring the humidity work based on the interaction of the sound wave with the surface of the sound wave with the surface of the material. These sensors will change its properties of the material in response to the moisture in the air. SAW are generated by applying electrical signals to the transducer by creating the mechanical wave that travels along the surface of the piezoelectric material such as quartz, crystal, or aluminum nitride. When humidity present in the air, the water vapor interacts with the sensor, causing the changes in the mass of the surface or changes in the signal provide a direction indication of the humidity level. Components. The sensor consists of piezoelectric material and the IDT that helps to generate and receive the acoustic waves. Applications. Weather monitoring systems used in weather stations to provide real-time humidity data. HVAC systems employed in heating, ventilation, and air conditioning system to maintain optimal humidity levels. Agriculture helps in monitoring humidity levels in greenhouses and soil. The DHT level sensor is a versatile component, making it a popular choice for projects that require humidity and temperature measurements. This is the humidity sensor.